Hi everyone, I hope that you're having a great morning. It's really exciting for me to be here today. I feel it's a great opportunity to be able to talk to you about what I've been working on for the past 2 years, which is mobile automation at Facebook. For the purpose of this talk, I'll focus on the Android side because that's what I've been doing for the past 2 years. The examples and the APIs that I will present will be focused on the Android side, but all the concepts that I'm going to approach and talk about can apply equally well to both platforms. But before I start diving into the actual contents of the talk, I want to give you a quick overview of where we started and where we are now. So beginning of 2014, we would release every month on mobile. We had a few applications. We didn't yet have that explosions of apps where we needed to take some features out of the main app. And to say the least, dog fooding was a suboptimal experience. I would compare it in terms of pain to stepping on a Lego while coming home drunk at 2 a.m. in the morning, which in no way is a good experience. And at the time, Simon Stewart sent me to Menlo Park to talk to product teams, and I ended up in a meeting surrounded by 10 managers who were wondering what I was doing there, and so was I. And I was telling them all about this great new tool that we were busy building in London, which was end-to-end testing. And much to my surprise, all of them looked at me with pretty surprised eye, and one of them told me, well, why would you do that? We all know it's not working. So that was a first. But if we fast forward 2 years, we are now releasing every week, so four times more than we used to. We have about 500 tests, end-to-end tests across several apps. About 10% of these tests run on every code change. And the video that you're seeing now is just one of these tests. I just picked one this morning and grabbed it from our CI system and just put the video. As you can see, it's a bit slow. That's because we rely on the x86 emulator, which is in a way the most performant emulators, but that's what we run on CI. And one thing that I think this project really helped with is that the quality of the apps that we're shipping is in no way comparable to what we had 2 years ago. 2 years ago, we would very often get a build because we are employees and we are supposed to dog food apps. We would try to log in, the app would explode in flames, and then you were locked out of your app for like 3 days in a row, which was kind of sucky. Now, instances where you do not log in anymore just didn't happen in the last year. It's pretty rare that we actually have these failures, and usually these failures have been caught by tests, and we just didn't manage to raise them in time. So I feel like we've come a really long way in this last year and a half. But one point I want to make is that end-to-end testing is really hard. It's true. It is really hard. End-to-end testing is very appealing. The promise of complex real-world scenarios from the point of view of an end user is very appealing to a lot of people. But there's also a lot of literature, and there's been a lot of discussions around the limitation of the approach and whether the approach should be dropped altogether because of the challenges that it presents. It might work well at a small scale, but whenever we try to scale that, we run into big problems. I want to cover a bit the challenges that we face at Facebook over the last 2 years. Oops. Okay. So the very first challenge is about exposing. Okay, thank you. The very first problem has always been about exposing actual failures. End-to-end tests do fail every often, but because of the scope of the things that can go wrong, because end-to-end tests treat an application and its backend as a black box, the scope of what can go wrong is beyond human availability. And being able to actually pinpoint what exactly went wrong when the code can come from the backend, it can come from infrastructure, it can come from your API, it can come from absolutely anything, is actually a big challenge. Another well-known challenge is about stability. I can't even count how many times I've heard end-to-end tests are flaky. It's not stable and it will never be stable. So that's been a big challenge, and I think that's been even more so of a challenge because everyone at Facebook was pretty convinced, especially in product teams, that it would not work to begin with. And it brings me to my next point, which is the testing culture. I think one of the great aspects of Facebook is that, on the contrary to many companies, we do not have test engineers. We do not have people whose job it is to write tests for product teams. Writing tests is every single engineer's duty and responsibility, and everyone needs to make sure that the features that they're writing keep on working. So when we go see some developer and we tell him, well, it's great, you've written unit tests, you've written integration tests, guess what the new flavor of the month testing is? It's end-to-end testing. And everyone around him has told him, well, it just doesn't work. We had to go through a lot of pushback. And the last point is about interdependency. And I think it's really something that is core to the concept of end-to-end testing. End-to-end testing, it's been talked about a lot. It relies on page objects. And these page objects are evidently a very crucial single point of failure in regards to end-to-end tests, because a single problem in a page object can affect a myriad of tests. So having rock-solid page objects that are extremely reliable and give you good signal is paramount to the success of end-to-end testing. So this talk is named Stable, Useful, Easy, Pick 3. There's a reason we chose this order. It's just that I couldn't go in the reverse one. So let's talk about making end-to-end testing easy. It's all about API designs, really. So you remember that test that I just showed you 2 minutes ago? This is the code for it. So as you can see, it's relying on two sets of APIs, one that is focused on the setup and one that is focused on the actual navigation and interaction with an app. These two APIs are the Scenario API, which is responsible for the test setup and setting up the context in which a test needs to run. And the other one is page objects. I assume that everyone in this room is at least a tiny bit familiar with the concept of page objects, so I won't explain in detail what they are. I will present how we chose to build them, because I think that's a pretty novel approach and yielded really great results. But let's start with scenario. So scenarios allow us to set up our tests. They basically provide an interface for setting up fixtures that provide automatic setup and teardowns. So this would allow us, for example, to create test users, to configure them, create relationship and friendship with them, post status in behalf of some user before we actually start the test, or simply put some files on an emulator so that we can later use them in the text context. The Scenario API's job is basically take all of these fixtures, build a dependency graph, and then when we build a scenario, resolve that graph asyncly and as fast as possible. Once we build a scenario, we can simply log in as a test user and get our first page object, which is a newsfeed page object where you land on every single test for every Android, Facebook for Android. So let's talk a bit about page objects. When I started 2 years ago, this is what page objects would look like. So this is pretty common WebDriver code. I don't think anyone who's used Selenium or Selendroid is going to be very surprised. A few things to notice, though, is that it's not very expressive. It's not bad, but it's not very expressive. The second thing is, and we can already see this, is that there are several options to choose from to do exactly the same thing. So for example, on the first call, we are using a weighting mechanism and expected conditions to make sure that some element is present. A few lines later, we actually rely on the driver to find an element and click on it. We have a few abstraction over text boxes that allow us to interact with them. But in my opinion, the biggest problems with these APIs is that it's never going to scale. It will never scale for the simple reason that if you expect 1,000 developers to learn about WebDriver APIs and to learn good practices on how to actually interact with an app under test in a way that is reliable, exposes the failures in a meaningful way, there will be way too much pushback. It will take too much time, especially if writing tests is part of the duties of your developers. So I'd say it's been a long effort, 1.5 years, but this is what up until pretty recently our APIs would look like. we introduced a UI abstraction. So the UI abstraction is basically a wrapper around the WebDriver API and encapsulate all the waiting mechanisms. It's a bit more expressive. It's not magnificent, but it's a bit more expressive. There's a strong emphasis on the visibility of the things that we are relying on. And just this design, by making sure that every single interaction or every single wrapper implements a visible interface that defines what should always be visible in expected conditions, allow us to wait for the state that we expect to be the start of every page object to be validated before we do any interaction. So as you can see, instead of having well-defined and hard-coded versions and locators, we have a bit more semantic APIs. We wait for the visibility of this current page object. Then we have a text box. We clear it. We type something in it. We type another text box, and we click on a button. And these APIs allowed us to completely get rid of something that had been the bane of our existence for months, which were stale element exceptions. I'm pretty sure anyone who's used Selenium knows about these. You are trying to access something that is no longer present, but in our case, the cache was invalidated, and then we would have crashes that would be in no way meaningful. One good thing about these APIs is that they are easy to learn. It's pretty easy to have a few interfaces that you can use and that we kind of coerce developers into using. And mostly the details of how elements are actually found and interacted with are completely encapsulated in the UI abstraction, and they are hidden from the developers. So they have way less things to care about. But then, as we had more and more tests and more page objects, we had a trend that started developing where people were actually reaching the edge cases where they wanted more complex interaction. So this was what led us to implement the selector API. So this is a complete rework of how we actually interact with an app under test. So it relies on two main concepts. The first one is the UI definition. UI definitions are, if you will, kind of a regex. We define what we expect the UI to look like. We don't need to define a lot of things. We basically care only about what's really important. So in this case, we define that we have a root that has some ID. It contains another element that has some ID. And this element has descendants that are two text boxes and a login button. The second part of these APIs is the selector themselves. And that's where the real value comes in. That's why we call it the selector API. I'll dive a tiny bit more after this. But the idea is that when you have this definition, selectors allow you to declare which elements in this UI are the ones that you actually care about for this selector. So for example, if I take the login button selector, so the last one, I take that definition and I select the login button locator. What this means is that whenever I ask the UI abstraction to give me elements or to click on something or to get me a text from an element, it will actually match the whole UI. Every element that I will get from the UI abstraction without entering into much detail will actually match. We will match that every single element that is declared in the UI matches this. So it will match your parents, your ancestors, your siblings, children, cousins, whatever. Everything will be there. So that's a great way for us to make sure that whenever we interact with something, everything that we expect is there, and it's actually correct. And then it really allowed us to expose semantic APIs. So instead of simply having wrappers that have their own set of APIs, we can rely only on the UI abstraction to actually provide these. So then the code becomes clear this, enter this text in this, click this button, and you can chain all of these actions. And it becomes extremely interesting when we have more complex scenario where we're not sure exactly what we want, but you want to expect something at some point. So this could be, for example, something that we use pretty frequently, UI scroll this page object down until this happens or this element is visible. And this had really great success in terms of people writing. They get these APIs way more quicker than they used to. One of the big wins is that it takes into account UI element relationships. And as you can see, you will see in the next example, that's really a pretty big win in terms of API design. It really focuses on expressiveness. People really, just from a glance, see what the page object is doing. And from an IDE perspective, whenever you write code, like the flow of actually writing this code is it's way easier than it was before. And the last thing is that it heavily relies on expected conditions at the framework level, and people do not need to actually declare these expected conditions, which was also a big win for us. So let's take an example. This is the audience picker for Facebook for Android. So this is what you get when you want to post a status update. You want to select the audience you want to share this with, who you want to share it with. And we had an interesting case where a team wanted to add a get selected audience to the audience picker page object. And they were struggling a bit with it. And the reason why is because what they really wanted is this text, friends. They wanted to know which one is currently selected. But the only way to know which one was selected was to actually find first the checkbox, because that's where we know which one is selected. But the only link between these two elements is actually their ancestor. So then, obviously, it becomes a bit more complicated. You have to actually find all the rows. Then for each of the row, you find the checkbox. If it's selected, you go back to the row and you find the label that you're looking for, and then you return it. And people just had problem with this because they wanted to go fast. They didn't want to spend 2 hours figuring out how they wanted to interact with the UI, so it was kind of a problem. But the selector API really solved this problem for us, because we can just declare that the UI definition in this case is about having a root, and this root has at least one row. This row has two descendants, which are a title, a label, and a checkbox. And our selector just becomes, from that definition, select the label locator, and add the predicate that for this one, the checkbox must be selected. And it works really well. And from, oops, what did I, yeah. And from this point of view, the interaction in itself just becomes UI, give me the text from this element that is that will be selected using this locator. So this really had a huge impact on how people are able to write tests and how they consider that it might actually be a good idea to invest time in writing these tests. So we successfully made writing end-to-end tests simple, and that was a pretty long ride, but we finally got there. But what about making it useful? Well, to make something useful, you have to use it. There's no way around it. So let me tell you a tiny bit about the development process at Facebook. There are a few characteristics that are not shared by all companies. For an enterprise, a company at this scale, to actually commit everything to master. We don't have development branches. Everyone works on master. Everyone pushes on master all the time. We just rebase on top of master, and that's it. So as a developer, what you care about is writing code, product, infrastructure, whatever. And how do you actually do that? Well, because we all work on master, we do need to rely on a pretty solid code review process. So every single diff that we send in order to commit code changes is supposed to go through code review. But code review takes time, and there are so many aspects to these apps that it's pretty hard to just rely on code review. So we built a really good CI system that is called Sandcastle that enables us to build and test the code that we are shipping every single time we actually put up a diff, we update it, we try to commit it every single time we will run the full suite of builds and tests that we know about. So for the purpose of this talk, I'm overly simplifying, but the idea is that we have two types of CI integration. Come on. Okay, so we have two types of CI integration. The first one is when we actually put up something for review, when you update it, when you try to commit, we run smoke tests. When this gets committed, this goes on to master, we run at regular intervals, we run continuous tests, and we create tasks for whenever things go broken. I'll elaborate a bit in a while on why this is important to run this continuous integration, especially at the scale Facebook operates at. So to quickly go over what happens on smoke tests, we run about 10% of the tests that we've written. We run a very small, very reliable subset of tests that is meant to test core features. They basically test the features that are not going to change tomorrow. Maybe the page object will change, fine. But the tests themselves very rarely change. They test liking, they test commenting, they test posting status, communicating on messengers. These are the core features that in 2 or 3 years are probably not going to change. They will still be there. They might have evolved, but that's fine. Page objects are there to handle the load of evolution. And whenever these tests fail, we report on your diff. Usually the contract is to report under 10 minutes what happened. So we have a summary where we say, well, listen, we have this number of tests failing, and just in case, because people are very apt at not reading this kind of stuff, we also comment on their diff to notify them that we had some failure and that they might want to see what went wrong. The goal of this test is really to prevent code changes breaking master to even make it to master. Then we have continuous tests. And this is really an automated experience. Anyone can write tests. These will get picked up by continuous bots. They will be run in stress testing until they pass. They will run. Once they start failing, we have another bot that will take them on another type of runs where we run them once a day just to make sure what the state is. Tasks will be created. We will bisect failures. When these tests are fixed, we re-enable them. This is a completely automated process. So running all these tests is great, and we run a lot of them. But one thing that really emerged really quickly is that it's very hard to know what went wrong when there are failures. We had developers come to us all the time and go like, I don't get it, like, it should work, but I have no idea what happened. And the only way we got rid of that problem is by building another tool. So we built a tool to help us diagnostic what happened, to help us investigate failures. And the only way we could really do it is by stuffing every single piece of log information that we could gather anywhere in our stack into a single page. So depending on the failure, you might have screenshots, you might have logcats, we always have video of the runs, Facebook-specific configurations, information about the state of the infrastructure, logs from Selenium, our runners, absolutely everything. And this really convinced people to actually use this stuff. And it actually solved the problem that we had for a year, where one of the tests that has been written pretty early was about search, where we would search for a user, but for whatever reason, when about 1 in 10 times when we would run this test, we would type something, and although the friend was there, nothing would show up. So we raised that issue to the team who were building that product, and their answer was like, not our problem. Probably not us anyway. And at the time, well, we didn't have really anything to show for that it was their problem. But after a while, when we started seeing these failures again, we realized that when we put the HTTP dump in place, well, actually all the data was there. So it took them a year and a half to fix this, and it's been in production for a really long time. But unless we were able to really easily show them that that's where it was actually failing, they refused to fix it. So it really allowed us to give a useful tool to developers to actually assess what was the state of what they were doing. And it's been really successful ever since in like actually fixing problems. So now for the big problem of end-to-end testing, stability. So everyone who's worked with end-to-end testing or talked to product teams or talked to developers has heard sometimes that it's not stable, it doesn't work. But what do we mean by stability? What is stability, like in the end? Do we care about whether a test fails 1 in 100 times? If we run it like 100 times in a week, if it fails only once, well, that's like, it fails 1 day out of the week. If we run it 100,000 times, well, it's gonna fail 1,000 times per week, and then it becomes extremely bad signal. So there's a balance there. And this is what a message that I really want to convey on what made us successful, is that we really need to focus on what is the most impactful problems that end-to-end had to provide for us. So you can't solve all the problems all the time. Sometimes you don't have the resources, you don't have the cycles. You need to find the most impactful problem and solve only this one. So for example, the problem that end-to-end tests are extremely bad at actually raising are transient failures. If something fails 1 in 1,000 times, it's just gonna happen, and you won't know why it happens. But that's fine. You can mitigate that by having retries and only reporting a failure if it failed 3 times in a row, and that's what we are doing. So now we know that whenever we report something, it is consistent. It's happening several times in a row. And that's the difference between solving all the problems or just kind of like pushing them on the side and mitigating them. But the most important thing in improving the stability is to actually understand what is going wrong most of the time. In order to be able to focus on the right things, we built a tool that allowed us to categorize every single failure that happened on master. And trust me, it's been a lot of work. We went through thousands and thousands of failures. Luckily for us, in many cases, someone breaks something and it breaks 50 tests in a row. So you can safely assume that if it's happening, the diff looks related, all these failures are related. So we categorize these failures in 3 buckets. On one hand, we had related failures. So these are clearly linked to your code change. We can clearly see almost from the get-go that you caused this just by the name of your diff, your problem related. So these covered about 15% of the failures that we were experiencing. Another type of failures were false positives. These were about between 1 and 5% of failures that we were reporting for a long time. So not that much, but these ones were really confusing because we could spend as much time as we wanted. There was no way we would ever figure what was happening. They would happen non-consistently, it would be really weird, looked like everything should happen correctly, but for whatever reason it did not. So these we categorize as true false positives. And then there's the bulk of 85% failures where the app was actually broken. There was a big problem in the app somewhere, but we could not link that to your code change. So this could happen for many reasons. For whatever reason, a product team launched A/B testing that our test users were magically put into, triggering code that no one expected, and then the app crashes. Or it could be simply that you are based on a revision where someone landed changes without code review or even running tests, and then the app is in a absolutely terrifying state. But because you're basically based on that revision, there's no way around it. So all of these failures we categorize as unrelated. And for the sake of honesty, we communicated to Facebook that all the unrelated plus false positive failures were false positives. What we really wanted was optimizing for signal. We really wanted that every single failure that we report should be code related, should be related to your code change. But to optimize for signal is then again about scale. So I'm sorry I can't actually put the axis, the vertical axis on this graph. I'm just not authorized to do that. But let me run you a bit about what this graph is about. In blue, you have the relative number of test results that we run on diffs. In red, you have the number of test results that we run on length when we try to commit. So both blue and red are actually what we run on smoke tests. The green one, obviously, because it runs continuously and we run everything, is more or less stable and runs even on weekends. It runs continuously throughout for 24 hours. It doesn't evolve that much. And we can clearly see that on smoke tests, there are big spikes, which are usually correspond to MPK coming online, starting cranking, and on weekends it falls down. But one thing that is important to realize is that the diff plus land are already quite above master, right? But these tests are about 40 tests. When we look at master, we're talking about hundreds of tests. But the number of results are already widely different. What this means is that whenever we run a test on smoke, given the number of pushes per day, the number of commits that people put off, we are talking about running a test when it's on smoke compared to continuous runs, an order of magnitude more. Which means that whenever these failures happen once every 2 weeks on master, on continuous, and it's pretty easy to see that, well, it might not be that important. When we run them on smoke, they start failing several times a day. And that's one test. But what about having 40? So suddenly it's like 100 failures. That means we might impact 100 developers that will have a terrible experience because we will report failures that they don't understand. We will block their commits for reasons that are not their own. So people got really pissed at this. So we introduced canarying. Canarying is the idea that we will run this test, but we will not report the results. And that's really important because we are unable to know, unless we run this test, what the stability will look like. We have to be able to run them without reporting to anyone. So that's the first use case for canarying. And the second use case is, as much as we like that to not happen, shit will go wrong at some point. That just happens. And sometimes these tails will start breaking, and someone will break them, and it will break for everyone, and it's gonna block everyone. So we need to be able to take these off and unblock people. So that's what canaries do. And the second thing, and that's what actually got rid of 99.97% of unrelated failures in terms of reporting. Let's say that this is our master on our source tree. You come into work in the morning, you're in a really good mood, you code. So you start working locally, you have a commit that you write locally, and master keeps on going for a while. And then you reach lunch, and you're ready to send your code for review, so you do. This goes to Fabricator, we run all the CI tests, builds, and end-to-end tests everywhere. And then we ask ourselves, all right, is it working? And it turns out it's not. You have a failure. The next question that we're asking ourselves is, what about the revision you're based on? Does it still work? And you might actually ask yourself, but wait, if that revision is on master, that means it was tested before. And that's true. But as I said before, the scope of the things that can go wrong is so large, and it might absolutely not be related to your actual code base. It can be another code base where your backend systems live. It can be something that is even completely unrelated to code changes. It can be infrastructure. It can be anything. So we chose to actually report failures only in the case where they happen only on your code change. And over the months of April, we had a 2.97% false positive across all the results that we were giving to developers. So almost 3 times out of 100, we would give false positives. When we put trunk-based reruns in effect, over the next months, we went down to 0.03% false positive. And ever since, we didn't have anyone complain about, wait, I got blocked by this, I don't understand what's happening. Sorry. So this is how we got end-to-end tests to be stable. I guess the reason why I'm really excited to talk to you today is because for 2 years, it's been a really long road. I can't even count the number of times where I was like, you know what, fuck this shit, like this is too much. No, like seriously, like, thank you. Like talking to people for hours, 40 hours a week when I went to MPK to convince them to write tests and just have them look at me and say, no, we're not gonna do it. And you're like, dude, I'm using your app right now, look at what happens. It took a while, but if we kept persevering and make it better, and we had people kick our asses all the time. And it was super painful. It was like really despairing to see how hard it became and how every time we had a win, we had a wall of huge failures coming after that. On-calls were the shittest experience ever. We had people join on the team, spend a week working 20 hours a day on an on-call that they didn't understand anything about. And go like, what have I done? So, retrospectively, it's been 2 years now, and it's been really hard. I'm not gonna say it's not hard. But what I really want people to stop saying is that it doesn't work, because it does work. It does work. We successfully managed to scale end-to-end testing at Facebook. The apps are becoming better by the day. Every single time we add a test, the apps get better. When I first added the first smoke test for login would be broken 5 times a day. 5 times a day. So I was there, really hopeful that I could get my test on smoke, but obviously it was broken 5 times a day. So every time I tried to enable it, everything went to shit. I was blocking people. It was just not doable. And one day, there was a bank holiday in the US. Best day of my life. The app was working, the bills were green, it was awesome, no one was working. So I landed the test, and for 6 months, login never broke. And it's broken maybe once or twice on really stupid stuff, but it got caught and got fixed. So I want to go quickly over the lessons that we've learned, and I think that were really valuable to us, and not only for end-to-end testing. There are many other areas in infrastructure at Facebook where we have people building amazing tools, but that will face the exact same challenges in the weeks and months to come. The first thing is, if you have to, you should have semantic APIs. There's no way around it. They're crucial if you want to scale. You need to have people want to write these tests because they are simple to write, they're actually nice to write, and they will give them meaningful results, meaningful errors, and it won't take too much time. This needs to become part of their development process. The big difference that we had compared to 2 years ago is that whereas 2 years ago, people were like, fuck you, end-to-end testing doesn't work, why would I do that? Now we have teams we didn't even know exist, for apps we didn't even know exist, come to us and go like, oh my God, this is so good, we won't write tests. And we had teams that were completely opposed to writing end-to-end tests who come to us now and go like, well, you know these 5 end-to-end tests that we have, they're really great. Can we have like 100? Which is not really the point. We don't want 100 tests for that feature, but that's another battle for another day, tomorrow probably. The next thing is focus on solving the most impactful problems. Don't attack everything at the same time. You can't spend too much, especially if your resources are constrained. You need to actually eliminate the problems when you can, and sometimes it's easy to do and you should do it absolutely. And sometimes you can't. And the best thing you can do is just mitigate them. And that's fine to push a problem on the side as long as you're optimizing for signal. Optimize for empowering engineers. In our case, these are the people who write tests, but your mileage may vary. It might be QA people, but optimize to empower them. Expose as much information as possible. If they know their job, they're gonna figure it out. Link failures to code changes whenever possible. That's the most single important thing around end-to-end testing. And then tooling. If you have the resources, spend some time, spend some money on tooling, because the scope of what can go wrong is so large that there's no way around it. You won't be able to rely on humans to do it for you if you want to scale. So what's next for us? First, we're working on improving the risk process at Facebook. We rely on dog fooders, on manual testing way too much. This costs money, this costs time, and as we already release fast, once a week is already really fast. But not only do we go fast, we go faster and faster. It might not be the case in 6 months, but what about in 1 year? What about in 2 years? Are we gonna release every day? Maybe, I don't know. But what I know is that humans will not scale to do this. We can't rely on manual testers and dog fooders because they won't be able to report to us fast enough for us to fix our problems. I'll give you an example. Taking a look at localization, it's a 1 month process. It already doesn't work well for when we create cycles. The next thing that I started prototyping next week is JavaScript using Flow framework, taking all the lessons that we've learned, all the APIs that we know work great, and write a new framework in JavaScript and Flow that will support React Native, because there's a pretty big involvement in React Native at Facebook, web, and native. And going further, these tests can be run in performance mode. We can collect performance metrics, we can run them in localization or internalization mode. So these are the big aspects that we will be working on this half. Well, I survived. So do you have any questions? Yeah. We do not run on devices. We run only on emulators on Android. We run on simulators on iOS. We have other parts of our infrastructure who rely on our APIs that do run on devices. So I think there's a lot of discussion around this. I feel like a lot of people have very strong opinions. I don't. The only thing that I would like to say is I have yet to meet someone who comes to me and goes like, well, you see this, your test would not have coded on an emulator. I'm still waiting for that to happen. And when that happens, I'm super happy to involve time and cycles into building like tests on devices, but we're not there yet. Yeah? So we simply bisect. Sorry? Oh, sorry. How do we tie test failures to the actual code change? Well, so for the smoke tests, at the moment it's a pretty manual process. We kind of, because it's been so good to us, like to understand what was happening, we still manage, we still go through all the failures on smoke tests. For continuous, it's pretty easy. We just like bisect, we run that on the latest known revision and we bisect to the actual failure. It's not always possible though. Like in many cases it is, but there are also a lot of cases where, for example, the web repository, which holds the backend systems, will actually break the app, and that happens. And that requires more attention. But usually when we reach that point, we are not really worried about end-to-end tests being flaky because everything went to shit at that point. Yeah. Sorry? Sorry? Oh, the new OSs and new devices that come to the market, how do we support them? Well, on iOS, the iOS team has been doing a tremendous job at reverse engineering different parts of UI automation and providing support for new OSs as they come along. They've been doing a really amazing job at that. On Android, we honestly didn't have a problem yet. So at the moment, because of scale and how much resources it takes, we focus mostly on running on Nexus 4 with API 17. That's kind of how we do it at the moment. It's actually extremely rare. I think I have seen it happen once or twice in the last year where actually failures would be completely device related and OS related. So at that point, I would say that this is an issue that we mitigate. We just don't want to get into that. Like the involvement in terms of cycles and capacity in our infrastructure to actually run that on every single API level on every device is just too much. It's not worth it. Yeah.
And let's say you have a bunch of features which are whitelisted in some countries or blacklisted in some countries. How do you manage this using a single page object across all locales?
Yeah. So that's a very interesting question. So how do we handle locale? So for example, if the locale is in Hebrew, like the text is not going to be written in the same orientation. So the first thing is for internationalization testing, we run all the tests that we know are localizable, where they use only IDs and not hard-coded strings. We use these tests and we run them once a day in every single locale. We dump all the strings that we can, we dump all the screenshots, and this populates a DB that is later on used for validation of translations. One thing to understand about the way we build page objects is that we do not expect them to be perfect. We actually don't care about rendering. That's another battle for another day. There are better systems to do that. We expect just the elements that we're expecting to be there. So whether they actually are on the top, on the bottom, on the side, or one way or the other, we just don't care. Like as long as the interaction that we're looking for is there and we can use it and the app doesn't explode, that's from a correctness point of view, that's fine for us.
So, my question is, let's talk about a feature which is not supposed to even show up in a country. Let's say Syria banned all the ads on Facebook, and you're not supposed to show any ads.
Oh, okay.
And
yeah.
you can show ads on other countries. So this is a feature which is blacklisted in Syria, and how do you put that kind of logic? How do you make your page object smart to know that, okay?
Okay, so I didn't dive into that detail. So the idea is, how do you handle uncertainty around what your page object should look like? So for example, given a certain country, you might not have some features. And actually there's a way more general problem than that. For example, if I land on my timeline as an Android user, the first thing that I'm going to see is my cover photo, my profile picture, a few buttons to like go to my photos or whatever. But if I scroll down, I'm going to start seeing stories. So the page object just doesn't work anymore. Just like we can't expect the cover photo or the profile photo to be there anymore, we just expect stories at that point. So the way to do this with the selector API is by adding either an optional statement in the UI definition where we say, well, it's great if you have that, and if you ask for a selector on this one, it should definitely be there. But if it's not there for another selector, that's kind of fine. And the other thing is we can add an OR operator where we go, well, this page object, the UI definition is this one or this one. And depending on where you are in the page object, if you scroll, for example, then simply the UI will look different, and the selector API is able to handle that. Well, like the local ID is a bit different. Sorry, the question was like, how do you, like on the local specific side, how do you handle that? You should never write, in my opinion, you should never ever write hard-coded localized strings as locator for your page object. That's just like everyone does it, because that's the very first thing that you see in the UI, right? So you see photo, so everyone goes like, by text, photo. That's the absolute worst way to do it, because if you do that, you tie your page object to a specific locale, and every time you change locale, it's not going to work well. And turns out that product teams change these strings all the time. Sometimes they're capitalized, sometimes they're not. Sometimes they change the actual class for the view, and suddenly it's not working anymore. We really strongly encourage either using IDs or using the class names. Class names not being the preferred way, but if really you have to, you can probably do that. Did that answer your question? Great. Yeah.
How do you reconcile the fact that teams complain that end-to-end tests take way too long to run and too much time to maintain? How long can your end-to-end testing suite take?
Great. Exactly the question I wanted. So that's been a point that's been raised by many people writing about end-to-end testing, and one of the challenges that end-to-end testing definitely has to overcome at some point. So the short answer is, for us, that's not really a problem, because we actually run a lot of these tests in parallel. Not in the sense that where we have emulators as a service and we just go give me 1,000 emulators and suddenly it runs, but just running 7 of them in parallel is already a big improvement. Actually running this test doesn't take long at all. Like you've seen the video, it takes like at most like 20, 30 seconds, which is arguably very long for a test. But where the actual cost comes from is starting an emulator, creating test users, configuring them, setting up your test. That's what takes a long time. So to answer the second part of your question, we run everything in parallel as much as possible. We are actually building infrastructure to have emulators as a service. And lastly, in regard to these tests, like smoke tests, the contract that we have is that we should be able to build and report all of these tests under 10 minutes. Depending on the repository, depending on the technology you use, it's a bit different, and some places are not that great. But on Android, it's pretty much fine, and I'd say that we have way more costly operations that basically, at the moment, put us in a place where we don't actually have to worry about that. On iOS, that's more of a problem. So on Smoke, I'd say about 15 minutes at the moment. The continuous runs, that runs, at the moment, I think we run 250 tests on Facebook for Android continuously. I think the whole test suite is about 30 minutes, about something like that, and bisecting takes another 30 minutes. So we usually are able to report and bisect in under an hour, which at that point is largely enough. Yep.
How do you make sure A/B tests don't break your end-to-end test?
How do we make sure that A/B testing doesn't break end-to-end tests? So that's been a huge problem for us. Like, I won't lie, there have been so many discussions about this. Everyone was super pissed about this for so long. Facebook prides itself in having the best engineers, but turns out we're really clowns when it comes to it. So basically the way we did it is really kind of stupid way to do it, but that's the only way we know works. So that's another mitigation right there. Take notes. What we do is we use a template test user. So basically the idea is that every single test user that we create is cloned and configured on top of an existing user that is absolutely stabilized in terms of A/B testing. Not in a sense where it won't change ever, but in the sense that if it has a specific set of A/B testing properties or specific set of experiments, and there are thousands of these experiments, and probably like millions at that point. We stabilize that, and if it starts having one configuration, every single test user will have that. So at that point, we build tools that allow us to say, well, between these two runs, what is the difference in between like experiments, A/B testing, gatekeepers, stuff like that. So we are usually able to pinpoint that to, I'd say, 100 changing parameters, but templating the test users really has helped us kind of just get rid of that problem. I think it's time to go. Well, last question? Okay, yeah.
How do you initialize your application state? Do you see data? Do you see your test data? Do you model your test data?
Well, okay, I think like we're really out of time. We can talk about it afterwards if you want. Thank you all for coming. Thank you for your attention. It's been really nice being here.